Right now, you are holding your phone, scrolling, typing, or reaching for your coffee with one specific hand. You did not choose it this morning. You did not choose it yesterday. 9 out of every 10 people reading this sentence are doing it with the exact same hand, the right one, and none of them ever sat down and decided that. No lesson taught it. No parent demonstrated it. No conscious decision was ever made. It was simply there, wired in, before memory even began. This is not a modern habit. This is not a cultural accident. It is a trace left behind by one of the biggest transformations in the entire story of our species. For thousands of generations, something was happening inside the ancient human body that nobody could see or measure. Long before anyone wrote a word, before anyone built a house, before anyone planted a single crop, the human brain was quietly rearranging itself. And the proof of that rearrangement did not vanish with time. It survived, carved into stone tools, etched into ancient teeth, printed onto cave walls in red and black pigment. Scientists studying these traces began noticing something strange. The same lopsided preference you carry in your own hand today shows up again and again in evidence tens of thousands, even hundreds of thousands of years old. That repetition is not an accident. It points to something deep, something structural, something that changed permanently inside the human body long before modern humans ever existed. To understand why 9 out of 10 people alive today reach with their right hand, you have to go back to two of the most important moments in the entire evolutionary story of our species. The first moment came when ancient human ancestors stood upright and began walking permanently on 2 legs. Before that shift, early hominins moved on 4 limbs much of the time, using their hands mainly for climbing, balancing, and grasping branches. Once walking upright became the default way of moving, the hands were suddenly free. They were no longer needed for locomotion. They could be used for something else entirely. That freedom did not happen overnight, but across enormous stretches of time, it changed everything. Hands that once carried the body now carried objects. They picked things up. They carried food back to camp. They carried infants against the body. They carried sharpened tools. And carrying, gripping, and manipulating objects placed entirely new demands on the brain. The brain had to control fine, precise movements in a way it never had to before. It had to plan sequences of actions in advance, one step leading into the next. It had to coordinate grip strength, timing, and force, all at once, without conscious thought. This new demand did not spread evenly across the brain. Instead, one side of the brain began to specialize in these skills more than the other. The second major shift was the extraordinary growth of the human brain itself. Over roughly 2 million years, the human brain nearly tripled in size. No other species on the planet had ever undergone growth like it. Not this fast and not this far. But a bigger brain is not simply a scaled-up version of a smaller one. As the brain grew, its 2 halves, the left and right hemispheres, began to divide labor between them. This division is known to scientists as lateralization. Certain functions became concentrated more strongly on one side of the brain than the other. In most humans, the left hemisphere became the dominant side for controlling fine motor movement. The left hemisphere also became the dominant side for producing and understanding language. Because the left side of the brain controls the right side of the body, the strengthening of the left hemisphere pulled hand dominance along with it. The result was a right hand that, in the vast majority of people, became more precise, more coordinated, and more heavily relied upon than the left. This is one reason scientists now believe handedness and language may share the same evolutionary root. Both depend heavily on the same side of the brain. Both require sequencing, timing, and fine control, held together in the right order. Both likely grew stronger together, reinforcing one another across hundreds of thousands of years. Some researchers even argue that the gestures early humans made with their dominant hand, pointing, showing, demonstrating, formed an early bridge towards spoken language itself. If that is true, then the simple act of reaching for something with your right hand today is tangled up with the very origins of human speech. The evidence for this ancient right-hand bias does not come from guesswork. It comes from physical traces left behind by real ancient people. One of the clearest sources of evidence is startlingly simple: ancient teeth. Early humans and Neanderthals often used their teeth almost like a third hand, gripping hides, plant fibers, or sinew between their teeth while pulling and cutting with a stone tool held in the other hand. This action left tiny scratch marks across the front teeth, invisible to the naked eye but clear under a microscope. Researchers studying these scratch marks found something remarkable. The overwhelming majority of the marks angled in one consistent direction, the direction produced by a right-handed left-handed grip. This pattern showed up again and again across different individuals, different time periods, and different regions of the ancient world. It suggested that right-hand dominance was not rare among ancient humans and Neanderthals. It was the clear and consistent majority, just as it is today. Fossilized arm bones add another striking layer to the picture. In many Neanderthal skeletons, the right arm bones are noticeably thicker and stronger than the left. This kind of asymmetry does not happen by chance. It happens when one arm is used far more often and with far more force over an entire lifetime. Researchers believe this pattern came from repeated powerful actions like thrusting spears at close range, scraping hides, and working stone tools, all performed again and again with a preferred hand. Stone tools themselves offer a further layer of evidence. Some of the earliest stone tools ever made, produced by early members of the genus Homo nearly 2 million years ago, show striking patterns in how the stone was struck and shaped. The angle and force of these strikes can reveal whether the toolmaker was likely using their right hand or their left hand to hold the hammerstone. Across large collections of ancient tools, right-handed strike patterns dominate the record, appearing far more often than left-handed patterns ever do. Cave art adds a third and strangely intimate layer of evidence. In caves across Europe, ancient people pressed one hand against the rock wall and blew pigment around it, leaving a stenciled outline behind. When researchers studied the ratio of left-hand stencils to right-hand stencils across many caves, right-hand stencils appeared far more often. This suggests the artists were holding the pigment or the blowing tube with their left hand while stenciling their right hand less often, since covering the dominant hand with pigment made the non-dominant hand appear on the wall more frequently. It is a strange, quiet, physical fingerprint of the same right-hand preference, left deliberately on stone, tens of thousands of years before writing existed. Comparing humans to our closest living relatives makes the pattern even more striking. Chimpanzees, our nearest evolutionary cousins, do show some individual hand preferences, but nowhere near the strong, population-wide right-hand bias seen in humans. Among chimpanzees, hand preference is scattered, roughly balanced between left and right across the population as a whole. Humans are different. Humans consistently show a population-wide skew, with right-handedness appearing in the vast majority no matter which culture, country, or era is studied. This tells scientists that the trait is not simply inherited from a shared ancestor in its current form, something specific to the human evolutionary path. Upright walking combined with rapid brain growth pushed the trait further than it went in any other primate alive today. The two hemispheres of the human brain communicate constantly through a thick band of nerve fibers called the corpus callosum. As lateralization increased, this communication became even more important. Skills learned by one hand could be shared, refined, and passed between generations far more efficiently once one hand became the reliable, practiced hand for detailed tasks. This had a knock-on effect on early human society. Toolmaking is not a skill one person invents alone. It is a skill taught, watched, copied, and refined across an entire group. If most people in a group already leaned toward using their right hand, that shared tendency made teaching and learning tool skills easier. A young member of the group, watching an older member strike stone with their right hand, could copy that same motion directly, without having to translate the movement from one side of the body to the other. Over many generations, this shared right-hand tendency likely reinforced itself, culture and biology feeding into one another, each strengthening the other. This is one reason some researchers believe the trait became so overwhelmingly dominant, not through biology alone and not through culture alone, but through both working together across an enormous stretch of time. Hunting may have played its own part in this story too. Throwing a spear accurately at a moving animal requires enormous coordination between the eyes, the shoulder, and the hand. A group that practiced and refined this motion together, generation after generation, with the same dominant hand, would have grown more accurate, more efficient, and more successful at securing food. Efficient hunting meant more calories, and more calories meant more energy available for an already expensive, rapidly growing brain. In this way, hand dominance and brain growth may have quietly fed each other, each one making the other slightly more likely to continue. Modern brain imaging has only confirmed what these ancient clues were already suggesting. Using scanning technology that ancient toolmakers could never have imagined, researchers can now watch the living human brain in real time. When someone performs a precise hand movement, activity lights up more strongly on one side of the brain than the other. For most people, that side is the left hemisphere, controlling the right hand. This modern evidence lines up almost perfectly with the ancient physical evidence: the worn teeth, the asymmetric bones, the struck stone, and the painted handprints on cave walls. Two completely different types types of evidence, one written in fossils and stone, the other written in glowing brain scans, are telling the same story from opposite ends of time. Left-handedness never disappeared entirely, and it never will. Roughly 1 in 10 people today still favor their left hand, and this small percentage has remained strikingly stable across history and across cultures. Some researchers believe this minority persisted precisely because a small amount of variation carries its own advantages. In physical contests, particularly combat and sport, being left-handed can create an element of surprise, since opponents train far more often against right-handed movement patterns. This may have offered a subtle, situational benefit that kept left-handedness from vanishing completely, even while the overall population continued to skew heavily to the right. So the trait we still see today is not an all-or-nothing outcome. It is a balance, shaped by millions of years of evolutionary pressure pulling in one dominant direction while leaving just enough room for the other to survive. Every one of these threads, upright walking, brain expansion, hemisphere specialization, language development, tool teaching, and cultural reinforcement, wove together over an almost unimaginable stretch of time. None of it was planned. No ancient human ever set out to become right-handed. No ancient human ever understood what was happening inside their own skull as they gripped a stone tool or reached for a burning branch. They were simply living, working, surviving, and teaching their children the same motions their own parents had taught them. And in doing so, without any awareness of it at all, they were quietly carving a permanent asymmetry into the human brain and body, one that would echo forward across hundreds of thousands of years. That asymmetry never left us. It survived the end of the Ice Age. It survived the rise and fall of every ancient civilization. It survived long enough to reach you, sitting exactly where you are right now. The same hand ancient toolmakers gripped stone with is very likely the same hand you just used to scroll to this sentence. You never chose it, and neither did they. It was chosen for you, slowly, invisibly, by 2 million years of ancestors standing upright, thinking, building, and teaching one another, one careful movement at a time. And now, every time you reach for something without thinking, you are repeating a motion whose true origin lies further back in time than language itself, further back than agriculture, further back than fire, in the quiet moment when the human brain first began to divide its labor between two hands and chose, almost by accident, which one would lead.